Let's take up another problem which was asked in IIT JEE 1999. Now the problem says there is a quarter cylinder of radius r and refractive index 1.5 is placed on a table. A point object P is there and it is kept at a distance of m times r from it. We have to find the value of m for which a ray from P will emerge parallel to the table as shown in figure. Now let's go slowly into the solution of this problem. Now the axis of this optical system, which is a quarter cylinder, will be the table itself. Now there are two events involved. The first event is a refraction from plane surface and the second event is a refraction from spherical surface whose radius of curvature will be same as the radius of cylinder. Now if we consider the first event, that is a refraction from plane surface, the distance of object from interface is m times r. Now the distance of image will be mu times distance of object because a ray is travelling from rarer to denser medium. The image formed by plane surface refraction will be at a distance of 3/2 m times r from interface and on the same side of object. Now these refracted rays will hit the curved surface and will be refracted out in air. Now this will act as an image, will act as an object for the next interface. Now for the next interface we have to use object image distance equation, and the distance from the pole of this curved surface will be obtained by adding the radius of the surface. So making relevant substitution in the relation, that is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Here we substitute mu2 as 1 and mu1 as 1.5. U as take care of it, it will be minus of bracket 3/2 mr plus r, and radius of curvature of the surface will be taken as negative. So making substitution we get 1 over v minus 3/2 minus 3/2 mr plus r in bracket is equal to 1 minus 3/2 divided by minus r. Now as it is given in the question that rays after refracting through curved surface, the curved part of cylinder, they become parallel to table. So the value of v will be infinity. So putting v as infinity, we get the value of m after solving equation as 4/3. So the value of m required is 4/3. Now it was a very simple problem involving two events, that is one refraction from plane surface and other refraction from curved surface. Let's take up another IIT problem which was asked very recently, and this was asked in IIT JEE 2004. Now this problem says, as it is shown in the figure, there is an irregular block of material of refractive index √2. Now there is a ray of light strikes the face AB as shown in the figure. After refraction, it is incident on a spherical surface CD of a radius of curvature 0.4 meter and enters a medium of refractive index 1.514 to meet PQ at point E. Now we have to find out the distance OE up to 2 places of decimal. Now again, here there are two events involved, and we are talking about a single ray. Now at plane interface, we cannot use the fact that when ray travel from rarer to denser medium, we have to multiply mu with the object distance. Now here we have to apply Snell's law, because the ray incident is no more paraxial. It's hitting the interface at an angle of 45 degrees. So we have to make use of Snell's law. If we apply Snell's law, we get 1 into sine 45 is equal to root 2 times sine r, where r is angle of refraction. Putting appropriate values and simplifying, we get the angle of refraction as 30 degrees. Now just let's analyze the whole situation. The base angle is given to be 60 degrees. Now for refracted ray to make 30 degree angle with the normal, it must be parallel to the base. Now that's a very important point. Now when we consider the next interface, which is a spherical interface, we are going to make use of object image distance equation. Now here, as the ray is parallel to the base and also parallel to the optical axis of the system, that is PQ, U will be infinity. So making appropriate substitution, mu2 will be taken as 1.514, mu1 will be root 2, U will be infinity, and radius of curvature of this spherical surface is given to be 0.4 meter, and V will be our answer. We need to find here OE. Now making substitution, we get the value of V as 6.06. We have to work out our answer up to 2 places of decimal. So we report our answer, that is OE distance, as 6.06.